Assalamualaikum and good afternoon, the committees and also the attendance of International Conference on Transnational Medicine and Health Sciences. My name is Muhammad Faisal from Universitas Abdurrahman Pekanbaru. Here I would like to present our research, which title in the slide. Okay, next slide. For the graphical abstract, we have reviewed the Sauceria costus or cos alhine contains three compounds, and we are trying to inhibit the spike glycoprotein virtually, and also RDRP. And the molecular docking show the binding affinity. And for the comprehensive explanation, we are going to next slide for the introduction and also the method and results. Throwback to the end of 2019 on 31st December before the New Year Eve in the Hubei district, specific on Wuhan, plenty of pneumonia cases was reported by Wuhan Municipal Health Commission. And also 2 months after that, on 27 February, SARS-CoV-2, this name now, spread to 47 countries. This virus causes more than 80,000 death cases. In Indonesia now, reported on 27 October 2021, more than 44.2 million persons confirmed with COVID-19 infection and more than 140,000 death cases is very sadly. Our nature gives us a lot of sources for medicines. Sauceria costus or Cos al-Hind was mentioned by Prophet Muhammad peace be upon him. He said that use the Indian woods since it contains 7 types of medicinal beneficiary. Among them is to cure pleurisy or lung disorder. Cos al-Hind roots previous research showed that the tree compound has biological activities such as antimicrobial, anti-inflammatory, and also specific antiviral, and then anti-cancer for the snarepicrin and the hydrocostus lactone. However, we are not able to find the clear insight regarding the molecular mechanisms of those compounds on spike glycoprotein and RDRP enzyme, which play a role in a SARS-CoV-2 survival. The potential SARS-CoV-2 inhibition could be a puzzle for us, and also the research questions show whether the cosonolide and also the two compounds has been will be an antiviral or no. For the methods, we download the structure compound and also protein structure in the database such as PubChem and SCSB. And for the ADMET prediction, we use online tools. For the molecular docking, we use the software such as Pyrex, and also the compound for the visualization. Yovia Discovery Studio has been used for this. And for the results in the next slide. As the first results, the prediction by Swiss ADME and pre-ADMET constructed the results like on the table. According to the Lipinski rules, all compounds obey the rules. make them belong to positively drug-likeness character. However, costanolide and dihydrocosta's lactone were not obeyed the rules designed by the TIC, which break the minimum of molecular weight. For the Atmet prediction of those compounds, on the table showed that cynaropicrin showed a positive for drug likeness and lead likenesses. Unfortunately, the carcinogenicity showed the positive results. It means cynaropicrin need to be further studied for the carcinogenic and also the low dose for this. We performed the molecular docking and obtained the binding affinity with the lowest. As you can see in the slide, the costanolide and cynaropicrin show the highest binding affinity on RDRP and also spike glycoprotein, respectively. Besides of this, the microbial results also contained in the dihydrocosta's lactone, which is show a high binding affinity on RDRP. In this slide, we visualize the pose of molecular docking that we perform by two softwares here in spike glycoprotein and the pose of the compounds. And also this one, the RDRP pose here in the cynaropicrin costanolide and also hydrocostas lactone are posed in here. As you can see from the molecular docking, the results showed binding affinity only. We visualize the interaction among the atom of compounds with amino acid residues. As shown in the slide, hydrogen bond formed in the cynaropicrin versus spike protein, which consequences has the highest binding affinity between the other compounds. The amino acids residues such as serine 371 and also 373 were predicted as the target of spike protein while treated by this compound. The compounds majorly formed by hydrophobic bonds while docked with RDRP and spike protein. However, the hydrophobic bonds sometimes could emit the high binding energy. In this slide, we reveal some amino acid residues target to keep the binding of the compounds on the RDRP, such as tryptophan, tyrosine, serine, threonine, were determined as potential inhibiting targets of SARS-CoV-2 RDRP. Indeed, the natural compounds have been seductive sources for preliminary studies. Costanolide, previously indicated as antiviral potent on several kinds of viruses. Moreover, several proliferative protein controllers also could be regulated by the costanolide. For both the hydrocasters lactone and cynaropicrin also exhibited an inhibiting potency on breast cancer progression proteins, and for cynaropicrin show the binding in a leukemia inhibitory factor receptor, which is leading to low expression of STAT3. In summary, we can conclude that cynaropicrin indicate the best ADMET, and also the cynaropicrin and costanolide show the highest binding affinity to spike glycoprotein and also RDRP. And then these amino acids might be the molecular target to inhibit spike glycoprotein. And also several amino acid residues such as tyrosine, threonine, tryptophan, and also serine may be designed as amino acids residues for molecular target of the SARS-CoV-2 anti-replicative viral drug. And for the suggestion, we need to do the in vivo study using cynaropicrin and costanolide, which is recommended to be performed in assessing the safe dose to prevent the carcinogenicity and mutagenicity. That's all for us. Any question?